Okay, so now we will render the final output of our edition, for which you can simply press here at render and it will go to this window. Please select here more options and widen it up. So here are all the options for the rendering process. Here you have the output file and folder. You can change that if you want. Here you have the profiles of the containers or of the video formats we can choose to proceed with the encoding. These are default formats. These are custom profiles that I've created. I'm gonna show you how to create specific profiles, but for a 4K project, for example, if you wanna select the NVIDIA H.265 encoder from MP4 container, you could just select this option here. Or if you wanted the VP9 from the Webm container, you would select this other one. Let me show you first this one, the HEVC. In here you would select the quality. If you see, the greater the quality, the lower the number of the quality scale of the video, and the greater is the audio scale number as well. So this first scaling number, it shows you how much compression you are applying on the video for this rendering. That's because the lower the number here, the less compression you have, and the better the quality, and the greater are the bit rates for the resulting video. In the audio here, in this case, for this profile is the bit rate. So the greater the bit rate, the best will be the quality of your audio. Here is the encoding speed. First, you should pay attention to use the exact number of threads you want. For example, my notebook has 6 cores with 12 threads. So if I want to use all the threads of my processor, I should set here all 12 threads, because by default it comes with only one thread, and will be a lot more time consuming for rendering, even if I set this encoding speed to the maximum. So you gotta set this to the maximum if you want, and also increase as much as you can the number of processing threads here in order to get the fullest from your processing capacity during your rendering process. Here at the scanning, you should also force progressive. I believe it's not necessary because we have already set the project to as a progressive, but just to be sure, select here as progressive. Here, if you wanted to rescale your project, it's not our case, and that's it. So if you press here, render to file, it will start rendering this edited video and audio that we've created. But there's still one problem here, which is the fact that this default profile here, it doesn't use the NVENC encoder. It uses another H.265 library, which is the libx265. And as a result, the encoding process will not use our graphics card as we want. It will use this library, libx265, which is a software-based encoding, and it will use the threads here, but it will take much more time if compared to the encoding using NVIDIA RTX 2060, which is my graphics card. So I gotta change this profile here to another profile which uses another codec, not this LibX265, but the HEVC NVENC encoder. And that's the same encoder we used at OBS, and now that we're gonna use here as well. So for that, as there's no default profile here for any of the NVENC encoders, not for the H.264 nor for the H.265, all the profiles here, they use a lot of formats and codecs, but none of them use the NVENC encoders. So that's why I created these other custom profiles. And for creating a custom profile, in order to set any of the two NVENC encoders we have for using our graphics card, we gotta create a new profile by pressing here. And for that, you just select any model profile you want, for example this one, MP4 H.265, and click on Create New Profile. So here are all the parameters for that profile we are creating. First, the profile name, for example, test, we can put any name. The extension, if we want to create a custom profile for using the NVENC H.264 and 5, which are from the MP4 container, we should let the extension here as MP4. If we were creating a Matroska profile, we would let the MKV and so on. If we were creating a VP8 or VP9 Webm profile, we would set here Webm extension and so on. So here you have all the parameters that the container is going to use along with that encoder. And basically let's set the same parameters that we set at OBS. You don't have to use these properties here. The format will be automatically set. You also don't have to set it here. Now, very importantly, the video codec, it will not be the LibX265. This codec is software based, it's not hardware based, and we want a hardware based codec, a codec that uses our graphics card. So that's why we'll change this video codec for HEVC NVENC. This is the NVENC H.265 video codec. The audio codec we let the same AAC. Here you can erase that. The CRF parameter is not accepted by HEVC encoder. The quality control we have for HEVC are basically two. The one we used at the OBS, which was the CQ. For example, we could put here CQ 15, the QMin 10, and the QMax 20. That's similar to the parameters we set at OBS. At the first rendering of our videos, we set the encoder as the HEVC NVENC. The audio encoder, we set the AAC, and indirectly controlling the bitrate or the quality of the video, we set the CQ, constant quality. There we set as 30, and the QMin we set to 25, and the QMax we set to 35. But here, as it's the second rendering of the same video, we could use better values for keeping the quality and not deforming it too much. Here at the quality it's the same of here the CQ. We could put 15. here at the bitrate of the audio, if you wanted to set a goal bitrate for the audio, we should put 384, and these are the possible values for the speed. If you see here, the encoder speed, it has 4 options, and these options are also a value for the preset parameter for the codec, and the slower value is of course the slower option, but it's the best quality option, so can keep these 4 options. And here we just select again the test. Every time you change anything on the profile, it goes to the first profile here, but then you go to the test again, and you can decrease the encoding speed to the slower option. You see that the preset is set here to the slower value. You keep the maximum for your threads, your processing threads here. Progressive scanning, and that's it. So with this new profile, a new custom profile here, we're setting a video codec which is not software based as this default profile here, Kdenlive. It's a NVENC or NVIDIA hardware based, GPU based video codec, HEVC, NVENC, and we are controlling the quality with the CQ parameter. If you wanna edit any profile you've created or any pre-existing profile, you can just click twice and you go again to these configuration options. You can change the profile name or any other thing you want. For example, here we could let just the preset slower, which is the best quality. And here, for example, we could, instead of using the constant quality parameter CQ, we could use the QP or the quantizer parameter, which is the other option for controlling the quality of our encoding in the case of HEVC or H.264 NVENC encoders. You have the CQ and you have the QP. Just have in mind that the other quality parameter very used at other encoders as Webm encoders, which is the CRF. It's not accepted here at the H.264 or the H.265 NVENC encoders. So there are only 2 options for controlling the quality, which is the CQ or the QP parameters. So as we've used the CQ at OBS, let's now use for the same encoder, HEVC and NVENC, the QP or quantizer parameter with a value of 15. You click OK and you select the profile again. And now, as you see here, you cannot select any different preset value. Only the slower preset will be possible, and that's the best preset value we can choose because it gives the best quality result. Let's just change the name here of the file for test. And that's it for starting to render this edited video and audio using this custom profile with the HEVC NVENC hardware-based video codec and the AAC as audio codec with the QP as 15 and the preset as the slower, and using all our processing threads in a progressive scanning. We now have just to click render to file and wait. So it's started the encoding or the rendering process, and it's giving us 14 minutes to finish the whole process. And as you see, it's similar to the length time of the video, which is pretty faster than if we had used any software-based encoder, including the H.265 libx software-based encoder. For software-based encoders at my computer, I've tested already, and it generally takes 4 to 5 times the time of the video length to conclude the rendering. But when I use the NVENC encoders and make use of my graphics card, it takes around the same time of the video. For example, if I have 1 hour edited video to be rendered, it will take around 1 hour for my NVIDIA graphics card to process that rendering, instead of 5 to 7 hours if I had used the software-based codecs. So for checking out if your NVIDIA card is really processing that, you can click here at the NVIDIA X server settings, and here you have 100% of utilization of your video engine. And you also at the system monitor have some main processor work. If you see here, my Core i7 processor is also working some of the rendering, but it's way below the workload if we had only set the rendering to the main processor and not used the NVIDIA graphics card. So most part of the rendering it sends to the NVIDIA graphics card if we use the NVENC encoders, but still it keeps some processing that I'm not sure what it is about at the main Core i7 processor I have, but keeping the considerable diminishing of the rendering time compared to if we had used any software-based encoder. So this is the most efficient way to render any video, which is by creating a custom rendering profile that makes use of your NVENC encoders so that the processing can be automatically sent to your NVIDIA card, as you can see here, and avoid consuming all your main processor capacity while also diminishing a lot the time for the overall rendering. If I, for example, had used the H.264 or 5 software-based profiles or encoders that by default comes with Kdenlive, for these 10 minutes, it would have taken, for example, 25 or half an hour for the rendering to occur. It's generally 5 to 7 times the length of the video for the rendering to conclude. But as I have created the custom profile and set the video encoder as either the HEVC or the H.264 NVENC, and as most of the processing has been sent thus to my NVIDIA graphics card, then I have diminished the timing for the rendering for around the time length of the rendering video. So I'll just stop the video right now until it concludes the rendering here, and then I'll start recording again to show you the resulting file properties of the rendered file. So see you in a moment. Okay, so now our rendering has finished, as it shows here at the job queue. And now if we go to the output folder, we will see our result rendered video test.mp4. And if we click to see its properties, we'll see the mp4 container type with a size of almost 510 megabytes. And if we go to the audio video tab here, we'll see the 12 minutes of length. The container is the QuickTime from which the mp4 container is derived. The video here now is 4K, although our original video was 1K. The codec we used was the HEVC NVENC or H.265 with the main profile. For 10 bits videos, you also have the profile main 10, which is another profile value you can set, but we've used the main profile. The frame rate 60 frames per second, and here the video bit rate is a reasonable one. As we've been saying, we are not directly controlling the bit rate either for the video or for the audio. For the audio, we've set the 384 kilobits per second bit rate, but it's also free to lower that if the encoder considers that there's no gaining in maintaining that bit rate so high. So it has downscaled the bitrate of the audio to 128 kilobits per second. But the most important, the video bitrate, it has kept at around 5 megabits per second, which is nice. If we wanted a higher bitrate for the video and maybe for the audio as well, we should have set a lower value for our quality control parameter, QP, or eventually tried the CQ parameter instead, as we used at the OBS, or even try to set directly the bitrate by setting the video bitrate and the audio bitrate directly at the custom profile we created. But one thing that I always do when I'm comparing the results of my output files in order to see which one ends up better than the other is to calculate the size of the file for 1 hour of video. For example, here for 12 minutes we got a file size of around 500 megabits. So let's see, for 1 hour, which would be 60 minutes, divided by 12 multiplied by 510. If we had a 1 hour encoding video with these configurations, we would have ended up with a 2.5 gigabytes resulting output. So if we want to try another configuration to see if we can reduce better the size of the file without compromising the quality of the video, first we have to check the quality of the video. We cannot diminish much because we are already at a 5 megabits per second for a 4K video, which is not that much. It's reasonable, but generally 4K videos have around 10 megabits per second bitrate, but in our case the original video was in 1K and our video has very low complexity images. We are not filming the nature or any other natural pictures. That's why in our case the bitrate tends to get much lower than it would be if we were making any real filming, especially high illuminated landscapes, because in the dark the bit rate also drops a lot, and that's expected to do so for economizing the size of the file, because for a dark image you generally do not need too many pixels to represent that. So that's why we generally keep it as a variable bitrate for the encoder to be able to analyze each frame image and try to set for each image a custom bitrate, the least possible, without compromising the constant quality we aim to achieve. But let's go back to Kdenlive and try a different profile configuration. So for that, we are not creating another one, we are just altering this one. Let's set the rate control explicitly as VBR. We can use the option with the HQ. So the rate control, we will set the VBR HQ. And now for the constant quality, we will set the CQ as at the OBS. And we'll set a much lower value here, for example 1. Because this is already the second rendering of the same video, so it tends to drop much the bitrate, and we want a better bitrate compared to the 5 megabits per second that we achieved on the last rendering. So we'll keep here the least value possible for the constant quality parameter. And now let's try again. Don't forget to always select here again, because it automatically goes back to the first one when you change any parameter from your profile. Let's just set here as the name as test2 and click render to file again. So I'll stop the video again and see you within 14 minutes. Okay, now we are finishing our second test for this edited video and audio. And instead of the QP parameter, we've now used the CQ. And now let's see within a few seconds what has changed in terms of file size and bitrate. Okay, now it's finished. You can clean up here. Let's go to the folder. Here is the test2 file. As you can see here already, it has a much smaller size. Let's see the properties. So it has 51 megabytes instead of 500, as with the first test we've done. So you can see here already that the CQ parameter we used to encode this second test, it takes much less size than the QP. And if you go to the audio video here, you see why. Because it has dropped drastically the bitrate from 5 to 0.5, so it has diminished to 1/10 the video bitrate, and as such it has also diminished in the same amount the file size, which depends basically on the frame rate, that in this case is the same, and on the video bitrate. So the resulting audio bitrate was the same, 128 kilobits per second, but the video bitrate has been much lower. So if we extrapolate to 1 hour, it will be 5 times this time length here, and also 5 times this file size here. which would give us a final output for 1 hour of 250 megabytes, which would be actually too reduced. So probably if we watch these two videos, probably this second one would be a useless video for most of our eventual applications, because either for 1K or for 4K, the average bitrate here would be at least around 3 megabits per second or 5 megabits or even 10 megabits per second, and never around 0.5 megabits per second. Maybe for a very low latency streaming this would be useful, but not for our purposes, which will be mainly for archiving our screen recordings. So you gotta test and then watch. Let's first watch this one to see that the quality will be very low. Maybe not that much.
Encoder, this container, it MP4.
Well, it's pretty much readable, so maybe because of the nature of our recordings. So if you find that as a sufficient quality, but I would try the QP, which resulted in this first one, instead of the CQ, which resulted on this other one. So let's see this first one with the QP. And it has a better quality. Okay, so now let's change our profile, and we'll keep the same video codec HEVC NVENC and the same audio codec AAC, but now as a rate control value, instead of a variable bitrate, we're gonna use a constant bitrate CBR HQ, and instead of CQ or QP as constant quality parameters, we're gonna use directly the video bitrate, and we'll set as 30,000 kilobits per second, or we could set as 30 megabits per second, but I'll keep 30,000. And we'll also set the mean rate as the same and the max rate also as the same. Don't forget to set the unity here, kilobits, which means kilobits per second for Kdenlive. Okay, so select again the profile. Don't forget that whenever you change anything on the profile configurations, it will automatically go back to the first one here. So you gotta select it again, and as you see, now the video codec is still the same, HEVC NVENC, the audio codec AAC, the rate control we've changed to CBR HQ, the video bitrate we've set to 30 megabits per second, the min rate and the max rate we also set to the same 30 megabits per second. And now let's see the results for this third configuration trial. Let's render the file and we'll go back within 16 minutes. Okay, so now we are finishing our third test with our HEVC NVENC encoder, but now using constant bit rate. And now let's go to the output folder and see the result compared to the other tests we've done. So this third test, we got a much greater file size because we've set the bit rate very high, 30 megabits per second, compared to the very low bit rate of 0.5 megabits per second on the test 2, or compared to the still small 5 megabits per second on the first test file. So let's check the properties for the third file, and still we have not yet got a 30 megabits per second, but we got a much higher video bit rate, although the audio bit rate stayed at 128 kilobits per second. So for the video bit rate that we tried to get as a 30 megabits per second, we actually got 12 megabits per second, which is lower than what we wanted, but is much higher than what we got so far at the first try, which was around 5 megabits per second. So here we got more than double the average bit rate of our first test rendering result. This is an average of 12 megabits per second. For having an idea of the actual bit rate of every frame of this file, what we can do is open it using VLC, and here at VLC we select Tools, Media, Information while playing the video. What should be a constant of 30 megabits per second, including the mean and max. As we said at the parameters, it varies a lot, and that's because it's very difficult to control the bit rate on modern codecs, and that's also why we seldomly use a direct bitrate control. What we do is use a constant quality parameter instead, and we delegate to the codec the controlling of the bitrate, because every time the encoder can drop that bitrate lower, it will drop, for example, to a 1 megabits per second, but we still got a very good quality. The quality would be much more if our original video had been recorded in 4K already. We are kind of upscaling a 1K video to a 4K. Okay, now after testing those 3 rendering configurations for our NVENC H.265 encoder, now let's try another encoder, and this time we're gonna use a software-based encoder, and as you see, it will take much more time to render, so I had to diminish the video that we want to render to only 30 seconds. And as parameters, we're gonna use the following parameters here. As the format, we are forcing the Webm format. If we do not use this explicitly, it will be used the MP4 container and format instead, and what we want is Webm container. And as the video codec, we are setting the VP9 encoder, whose name is libvpx-vp9. So as a format or container, we are using Webm container, and as video codec, we are using libvpx-vp9 encoder, which is a software-based encoder as good as HEVC for 4K resolution videos, but the disadvantage, at least for now, is that NVIDIA has not yet designed or implemented any VP9 version for using NVIDIA Graphics Card. So any VP9 codec that I have tested, it is software based and not hardware based, and as such it takes 4 or 5 times the length of the video to complete the rendering, while the NVENC encoders take exactly the same time of the length of the video to complete the same rendering. So you set the format parameter, Webm, you set the video codec, libvpx-vp9, and as the constant quality parameter, instead of CQ or QP, you can also use the QP here, but not the CQ. Instead of them, the main constant quality parameter is the CRF, both for VP8 as for VP9, and as a value we'll set the value as 15. The video bitrate will set as automatic or as 0. It's actually optional, but I'm just showing you that you can set the video bitrate as 0 for automatic, and as audio codec we are setting the Opus codec. Is a very used encoder nowadays, so instead of AAC we are now using Opus together with the VP9, both encoders from Google. This preset, it's not needed because it's already set here below, and the audio bitrate you should not use, because if you try to use, the rendering will fail. You must leave for the codec to set automatically the audio bitrate. And the preset we'll use as slower. Okay. Set again the profile. Check if everything is okay. Format Webm. Video codec libvpx-vp9. CRF constant quality control parameter 15. Video bitrate automatic, and audio codec lib Opus. Slower speed, 12 threads, progressive scanning. Okay, so let's render. Just an observation, I also reduced the length of the video to only 10 seconds, because as now we are using a software based encoder, you see that it will take much more time than the NVENC encoders for rendering the same amount of video. So I had to diminish the length of the video to be rendered so that it will not take too much time for our test. So now just click render to file, override the previous test I've done. Okay, for the 10 seconds you can see here that it will take around 60 seconds, so it will be 6 times the time of the video to complete the rendering time, and that's, as you remember, much more than what we had for the NVENC encoders, hardware-based encoders, which had a proportion of 1:1. For NVENC encoders, if we had 1 hour videos to be rendered, it would take exactly 1 hour to render. But now, if we had 1 hour video to be rendered with VP9, or I believe even with VP8, which is less demanding, it will take around 6 times the length of the video, that is 6 hours, to complete the rendering for this 4K 60 frames per second project. So, especially when you're with a 4K high frame rate project, you should prefer the NVENC or your hardware-based encoders for keeping your rendering time much lower and almost equal to the video length to be rendered, instead of 6 or 10 hours of rendering time. So now we finish to render these 10 seconds, and now let's see the result. Here is the result of 9 megabytes for 10 seconds. So for 1 hour of video, using these configurations for VP9 encoder, it would end up, for 1 hour of video, 3.2 gigabytes of video, which is pretty nice, and it indicates a good quality of the video, especially for 4K videos. And if you go here to the audio video tab, you'll see that we have succeeded in using the Webm container. Actually, the type here is shown as MP4, but the container here is Webm. The codec used is VP9. We kept the 4K resolution and 60 frames per second frame rate. The audio codec is Opus now. Instead of AAC, we managed to encode using the Opus encoder. But as you see here, there's no explicit bitrate for the video nor for the audio. So what we can do is to open the file at VLC in order to see on real time the bit rates for the video and for the audio. Select here Tools, Media Information, Statistics, and here you have the real-time bitrate. Let me just turn down the volume. This is the bitrate for the video, and for the audio it doesn't show, and actually I think there's no way to know what we call when using the Opus encoder. But for the video, at least, it has resulted in a good quality, both for the bitrate as for the file size. It's a good file size for a 4K video, and the quality is also nice, as you can see. Into what we call, and the quality of the image is in general very nice. So with this VP9 codec, we had a great encoding quality for the image. We had a good compression ratio, but we had a low efficiency in the performance of the rendering if compared to NVENC encoders. So because of that, I would always prefer to use NVENC encoders instead. So that's basically it. If you wanted to try any other software-based encoders as lossless HUF YUV, which results in an extremely large file size, because both the video as the audio here is of lossless quality. You could also try the flash if you wanted for any reason. The window media player format if for any reason you need it. Or the GIF high quality if you wanted to produce GIFs. But generally the most used and common codecs are the NVENC codecs, MP4, H.264 and 5, and the Webm codecs, VP8 and VP9. And by using them, you just have to be careful with the parameters to use and maybe make a test with a small size of your video to see which parameter values balance better the quality of the image or of the encoding, the file size, the bit rate, the average bit rate, and the actual bit rate for the frames along the video, as well as the rendering time. So that's it. That's our introduction for this process of recording your screen, editing the audio for taking out any noising and normalizing the audio level, and finally for editing the video at Kdenlive and ultimately rendering for a second time. The first time is at the OBS recording, and the second time now is after the edition of the audio and the video for reaching a good quality of the images of the video frames, for getting a nice video size, as well as for getting a great rendering time and not spend 10 hours for rendering and 1 hour video if using software-based encoders instead of NVENC hardware-based encoders. So I hope you liked this course, and if you want a more thoroughly set of information about FFmpeg or about any specifications of the encoders or of the parameters, I'll leave some references attached to these lectures. But I hope the content we tackled so far has been useful for you to create your own screen recordings, as well as edit the basics regarding its audio and video, and finally render that to a final output video, choosing the best hardware-based encoders you prefer. So see you on the next courses. Bye bye.